Hello once again, my mortal audience. My name is Shogun, and I welcome you to this week's edition of Science Weekly. To those new to this channel, this is the show on YouTube where we cover the latest scientific developments and discoveries across various scientific disciplines, brought to you by yours truly. Let us not waste any more time as we hop into the video. Buckle up. For our first story, we have positively astonishing news tied to the recent UFO situation that occurred in the USA. The Pentagon has launched a new online portal dedicated to reports on unidentified anomalous phenomena, UAPs, commonly known as UFOs. The website, ro.mil, is a work in progress, but it already provides valuable resources. While certain features, like an online contact form, are labeled as coming soon, the current version offers 8 videos showcasing UAP sightings, archives of congressional reports and briefings, press releases, and links to additional references. Air Force Brig. Gen. Pat Ryder, the Department of Defense's press secretary, emphasized during a recent briefing that this website aims to be a comprehensive hub for all publicly available information related to the All-Domain Anomaly Resolution Office, AARO, and UAPs. This development signifies growing attention and credibility within the Pentagon regarding UAPs. Deputy Defense Secretary Kathleen Hicks has assumed direct oversight of AARO and its director Sean Kirkpatrick to expedite its development and the website's launch. Hicks stressed the importance of transparency in AARO's work, asserting a commitment to sharing discoveries with Congress and the public, while upholding national defense and intelligence interests. Once fully operational, the website will serve as a secure platform for current or former government employees, military personnel, and contractors to submit UAP reports. The Defense Department announced the launch of a secure reporting tool for this purpose in the fall, with plans to introduce a reporting mechanism for the general public in the coming months. Additionally, civilian pilots have been encouraged to report UAP sightings to air traffic controllers, and AARO will receive UAP-related pilot reports, known as PIRAPs, from the Federal Aviation Administration. AARO classifies UAPs into 3 categories: airborne objects that defy immediate identification, transmedium objects or devices, submerged objects or devices that are not immediately identifiable, and exhibit behaviors or characteristics suggesting a connection to the first 2 categories. The Defense Department defines UAPs as sources of anomalous detections in one or more domains, i.e., airborne, seaborne, spaceborne, and/or transmedium, that are not yet attributable to known actors and that demonstrate behaviors that are not readily understood by sensors or observers. Notably, the website does not explicitly mention the possibility of extraterrestrial origins for UAPs. Concerns among government officials and lawmakers are driven in part by the potential for UAPs to represent intrusions by other nations, such as Russia or China, as exemplified by incidents like the Chinese spy balloon that crossed the United States and was subsequently intercepted by an Air Force fighter jet. I don't know about you folks, but I, for one, did not expect the dear government to place what is basically a soft disclosure in the public eye. However,
it is what it is. It is what it is.
For our next story, we observe AI pulling an absolute ratio on humanity once again, believe it or not. Artificial intelligence systems are rapidly advancing, achieving performance levels that rival or surpass human capabilities in controlled environments and simulations. Putting aside ethical and environmental concerns associated with AI and autonomous drones, a remarkable achievement has surfaced: an AI-controlled drone system named Swift that consistently outperformed 3 professional human drone pilots in head-to-head races. Swift secured victory in 15 out of 25 races against world champion human pilots on a challenging track filled with sweeping turns and sharp pivots, meticulously designed by a professional drone racing pilot. This aptly named system combines AI learning algorithms with a single camera and onboard sensors to perceive its surroundings and movements. Developed by Elia Kaufman, a robotics engineer at the University of Zurich, in collaboration with researchers at Intel Labs, Swift distinguishes itself by not relying on external motion cameras, a departure from previous autonomous racing drones. Kaufman and colleagues acknowledge the difficulty in achieving professional-level piloting skills with an autonomous drone. The robot must operate at its physical limits while estimating its speed and position exclusively using onboard sensors. Human drone racing pilots wear headsets providing a first-person view through a camera on the drone, which can reach speeds of up to 100 kilometers per hour. Similarly, Swift employs an onboard camera and an inertial sensor to measure acceleration and rotation, utilizing data ingested by two AI algorithms to determine the drone's position relative to the square gates on the obstacle course and generate control commands accordingly. Despite losing 40% of the races, Swift managed to defeat each human pilot multiple times and recorded the fastest race time, surpassing the best human performance by half a second. Kaufman and colleagues report that overall, Swift achieved the highest average speed across the entire track, identified the shortest racing line, and consistently operated closer to its actuation limits throughout the race. Guido de Kroon, a robotics researcher at Delft University of Technology in the Netherlands, noted in his commentary that Swift's true innovation lies in its deployment of a second artificial neural network, leveraging deep reinforcement learning. This network primarily learns through trial and error during training, applying its acquired controls to real-world vision in turbulent conditions. Both human pilots and Swift underwent training in a simulation of the racetrack. The deep learning algorithm explored various paths through the track's 7 gates to discover faster routes. With optimized control commands in place, Swift processed visual inputs during test runs on the course. De Kroon explains that the slight disparities between simulation and reality were addressed by a neural network, which improved the simulation and refined the system's strategy. While Swift's precision in navigating physical obstacles is impressive, further developments are required before it can operate in outdoor environments with unpredictable conditions, according to de Kroon. He concludes that given drones' rapid acquisition of sensing information compared to human pilots relying on delayed images, autonomous drones are likely to eventually outperform humans under these challenging conditions as well. Imagine needing drone pilots in 2023. If you hurt a plant, does it scream? It appears that Roald Dahl's imaginative notions may have some grounding in reality. Plants, it seems, have a way of screaming when they're distressed, albeit in a manner beyond our auditory perception. Instead of human-like screams, they emit subtle popping or clicking noises in ultrasonic frequencies. This intriguing discovery, as per a study published this year, suggests that these sounds could be one of the ways plants communicate their distress to the world around them. Evolutionary biologist Lilac Hadani from Tel Aviv University in Israel explains, even in a quiet field, there are actually sounds that we don't hear, and those sounds carry information. There are animals that can hear these sounds, so there is the possibility that a lot of acoustic interaction is occurring. Plants, far from being passive, undergo significant changes when stressed. One of the more observable transformations, at least to us humans, is the release of potent aromas. They can also modify their color and shape. These changes serve as signals to neighboring plants, either to bolster their defenses or to attract animals that can address pest-related issues. However, the idea that plants may emit sounds had not been extensively explored until recently. Hadani and her team had previously established that plants can perceive sound, leading to the question of whether they can produce it as well. To investigate this, they recorded tomato and tobacco plants under various conditions, unstressed, dehydrated, and with their stems cut. Recordings were conducted in both a soundproofed acoustic chamber and a typical greenhouse environment. A machine learning algorithm was then trained to differentiate between the sounds produced by unstressed, cut, and dehydrated plants. The sounds emitted by plants are akin to popping or clicking noises, with frequencies too high for human ears to discern, detectable within a radius of over a meter, 3.3 feet. Unstressed plants remain relatively quiet, while stressed plants become notably noisier, producing an average of up to 40 clicks per hour, depending on the plant species. Dehydrated plants exhibit a distinctive sound profile, increasing clicks as they become parched before gradually diminishing as they wither. The team's algorithm could successfully distinguish these sounds and even identify the plant species generating them. Moreover, it wasn't limited to tomato and tobacco plants. Other plants, including wheat, corn, grape, cactus, and henbit, were also recorded emitting sounds. Nevertheless, there are still unanswered questions. The exact mechanism behind the sound production remains unclear, although it may involve a process akin to cavitation, where air bubbles in the stem expand and collapse, producing audible pops, similar to human knuckle cracking. The study leaves open the possibility that various adverse conditions, such as pathogen attacks, UV exposure, temperature extremes, or other stressors, could prompt plants to produce sounds. Whether this sound production is an adaptive trait in plants or a byproduct remains uncertain. However, the implications extend beyond the botanical world. Other organisms could potentially perceive and respond to these sounds. For instance, moths laying eggs on plants or animals intending to consume plants might use these sounds as cues for their actions. For humans, this discovery suggests that we might be able to tune into the distress calls of thirsty plants and water them proactively, addressing their needs before they face severe dehydration. But the crucial question, according to Hadani, is who might be listening? The next phase of research will delve into how various organisms, both animals and plants, respond to these plant sounds in natural environments, shedding light on the broader ecological significance of this newfound plant communication. And for our last story, it seems that we are one step closer to understanding our own genetics. In a significant scientific milestone, researchers have achieved the full sequencing of the Y chromosome, marking the completion of a nearly 3-decade-long endeavor to unravel the smallest member of the human chromosome family. Last year, scientists unveiled a comprehensive gapless sequence of the human genome, but the Y chromosome remained a missing piece of the puzzle. Now, with this achievement, an all-encompassing human reference genome emerges, potentially harboring insights into male fertility. The Y chromosome, often shrouded in complexity due to its numerous repetitive sequences, including intricate palindromes, had long presented challenges in deciphering its entirety. The Telomere-to-Telomere Consortium, led by genomicist Orang Ri from the U.S. National Human Genome Research Institute, harnessed advanced sequencing techniques and innovative bioinformatic algorithms to piece together long stretches of DNA, finally providing a complete map of the Y chromosome. Dylan Taylor, a geneticist at Johns Hopkins University and one of the study's authors, emphasized the newfound opportunities. Now that we have this 100% complete sequence of the Y chromosome, we can identify and explore numerous genetic variations that could be impacting human traits and disease in a way that we weren't able to do before. Previously, gaps in the Y chromosome sequence, particularly those related to genes involved in sperm production, had led to erroneous assumptions in various studies, including the misidentification of previously unknown human Y sequences as bacterial DNA contaminants. Rajiv McCoy, a computational biologist at Johns Hopkins University, expressed the significance of this achievement, stating, "But we can now see the entire genome from end to end for the first time." The team filled in over 30 million DNA sequence letters to assemble the Y chromosome in its entirety, comprising all 62,460,029 base pairs. Furthermore, they rectified multiple errors in previously sequenced sections and unveiled 41 new protein coding genes. One notable revelation was the organized nature of the repetitive sequences on the Y chromosome, characterized by alternating blocks of specific repeating sequences, known as satellite DNA. This arrangement forms a visually striking, quilt-like pattern, as observed by Adam Philippi, a computer scientist at the U.S. National Human Genome Research Institute. In a complementary study led by geneticist Pil Hallest from the Jackson Laboratory, researchers leveraged the reference sequence to assemble Y chromosomes from 43 male individuals, half of whom represented African lineages. These assemblies spanned 183,000 years of human evolution and unveiled unexpected variations in the Y chromosome. Notably, the Y chromosomes displayed significant differences in size, ranging from 45.2 million to 84.9 million base pairs in length. Structural distinctions were also evident, with gene sequences preserved, but sometimes larger DNA sections reversed or oriented in the opposite direction along the Y chromosome. Philippi underscored the potential implications for understanding human health. When you find variation that you haven't seen before, the hope is always that those genomic variants will be important for understanding human health. The sequencing of the Y chromosome sets the stage for a new era in personalized medicine, particularly if sequencing technologies continue to advance, enabling cost-effective sequencing of entire genomes rather than select sections. However, Addressing historical injustices and enhancing diversity in research studies are essential to prevent healthcare disparities as genomics becomes more integral to medicine. The researchers conclude that as the complete, accurate, and gapless assembly of diploid human genomes becomes routine, what we now call reference genomes will simply be referred to as genomes. This achievement marks a significant step toward a more comprehensive understanding of human genetics and its implications for health and medicine. And there you have it, Chads and Chuds, that's all she wrote. I do hope you enjoyed this broadcast. Tune in next time, where we will cover some more news in a similar manner. Consider liking and subscribing so you don't miss any of my future uploads. Until next time, my mortal audience.